Hi, in this video, we're going to continue our discussion of qualitative changes of entropy, delta S. In this perspective, we're going to look at the idea of mixing, creating solutions or separating solutions into pure substances, and that's its effect on entropy changes. So let me take a look here. Let's put up a video. I'm sorry, let's put up a little calculation here, or a little diagram, sorry. So this is 18.3. So let's imagine that we have a container and it just has water in it, right? Just water inside. Pure water, liquid form. Then what we do is we weigh out some solid. Could be salt, could be sugar. Let's just, to make things simple, let's make it sugar. Now, granulated sugar, the white sugar that you buy in the store, is what's called sucrose. C12H22O11. It's what's called a disaccharide. It's an organic molecule, a hydrocarbon, has carbon, hydrogen, oxygen in it. And let's suppose that we mix those two together. So we're mixing the water with the sucrose. And here's what would happen. We would get liquid water. Of course, it's not going to change at all. But now we're going to have little sugar molecules dissolved in the water, right? Countless numbers, all dissolved, moving around in there, so forth and so on. Okay, we've now created a solution, or at least we've created a mixture. And the question in this topic is, what's the effect on entropy if we do something like that? And it turns out that if you have pure substances actually don't have very much entropy relative to other materials. Pure substances are essentially low in entropy. It is small values, okay? On the other hand, mixtures, when we make a mixture, essentially what we're doing is we're randomizing positions, right? We're taking positions for molecules and atoms that were fixed. So if you look at a sugar cube, for example, all those sugar molecules are just sort of stuck in space next to each other. Put them in water and dissolve in the water. Now they're all completely randomized, right? They're all mixed about there. So creating mixtures essentially randomizes, you're randomizing the positions of the molecules. And that has a tendency to increase entropy. Okay, so the entropy will increase as you make mixtures. And so in this direction, making a mixture, that's going to increase entropy, S for entropy. On the other hand, if you did the opposite, if you were somehow able to crystallize the sugar, that's essentially what rock candy is, right? It's crystallized sugar in the water. You do it by evaporating the water, but essentially what you're doing is you're decreasing the entropy by separating the materials, okay? So if you separate the materials into pure substances like we have here, then you're decreasing the entropy, okay? Relatively straightforward. So let's take a look. Example. So it says in here that we're predicting qualitatively how entropy changes with mixing and separation. For each system listed in the first column of the table below, decide if possible whether the change described in the second column will increase the entropy S of the system, decrease S, or leave S unchanged. If you don't have enough information to decide, check the not enough information button in the last column. Let's take a look at the first one. A mixture of xenon, Xc, gas and nitrogen, N2, at 3 atmosphere and 31 degrees Celsius. So constant temperature, constant pressure. The change is that an additional 2 liters, 2.0 liters of nitrogen gas is added to the mixture with the pressure kept constant at 3 atmospheres. What happens to the entropy? Well, you know, entropy is a extensive property, just like enthalpy is or heat is. The more of it you have, the more of it you have. So the more material you have, the more entropy you have. So adding more material will increase the entropy. An increase of entropy is delta S is greater than 0. Okay. A liter of seawater at 15 degrees Celsius. The seawater is passed through a reverse osmosis filter. You can purchase these on Amazon, which separates it into 750 milliliters of pure water and 250 milliliters of brine, very salty water. So what is it doing? It's separating the mixture into a pure substance. The pure substance is the 750 milliliters of water. So, you know, pure substances have less entropy than mixtures do. So if you're creating a pure substance out of a mixture, you're decreasing the entropy, and delta S again would be negative, less than 0. In the third one, we have 300 milliliters of a solution made from potassium iodide, which is Ki, dissolved in water. 0.5 grams of Ki crystallizes out of the solution without changing the temperature, right? Crystallizing. So what does that mean? That means it's forming a pure substance. Crystals, when they form, tend to be pretty pure. So you're taking a solution, a mixture, converting it into pure substances. Again, that's a decrease in entropy, right? Pure substances have less entropy than mixtures do. So again, delta S is less than 0. Okay. Good luck with this.